This video is going to talk a little bit about the definition of a function. The function is a really big part of algebra, and so we're just sort of introducing what is a function for now. We'll actually spend most of the year working with functions. So the first thing we want to realize is the first kind of way we relate two things we call a relation. A relation is just a pairing, again, of inputs and outputs, as it says on the screen. Oftentimes, we'll represent a pairing as an ordered pair over here at the right, usually written as x comma y. But again, we're really just relating two things. So down at the bottom of the screen, you'll see that we've got a list of inputs and then we have a list of outputs. So again, a relation is just saying that when we inputted 0, we output 0. When we inputted 1, we output 2. Think of this like just a machine. We're dropping a number in, a bunch of stuff happens, output number comes back. Again, we're just relating two things. The numbers that we're inputting, again, we call the domain. So 0, 1, 4, and 6, we could list and notice these kind of fancy brackets down here as the domain. And the numbers that we're outputting, again, we would call the range. And so those would be those numbers 0, 2, and 8. Notice since 2 is repeated, we don't have to list it twice when we're listing off the range. But again, we want to put those brackets to show that it's a set of numbers. Those are set notation kind of, or set brackets, a set of numbers representing, again, the range R. Now, a function is a very specific type of relation. For every input in a function, we'll get back exactly one output. So we've got 0 going to 0, 1 goes to 2, 4 goes to 8, 6 goes to 2. Even though 2 came back twice, that's okay. Every input only get back one exact output, only gave back one exact output. So again, we often call it the domain the independent variable. It's independent because we get to pick it. It's independent of anything around it, whereas the range is dependent upon what you picked in the domain. So oftentimes we call the range the dependent variable. We're only getting back 0 because we input 0. We only get back 2 because we input 1 or we input 6. What we get back is dependent upon what we started with. But what we started with can be any number we want to pick. So let's take a look at a few examples here of different types of functions or different ways to represent a function. So one type is the mapping relation. So kind of like we had on the previous screen, only now it's written in oval form. We're just sort of writing down the domain, we're writing down the range. And now -2, notice maps, we draw an arrow to -8, 4 went to 10, 0 went to -2, and 2 went to 4. That means this is a function. Every element in the domain, each one of those 4 numbers, mapped exactly to one place in the range. We could also represent a function as a table, so like we saw on the previous screen. So we've got the table over here, -2 to 8, 0 to -2. Again, fairly normal table there. But again, we'd always want to double check, are any of the inputs, any of the x values are repeated? If any of those repeat, then we're likely not a function. We've also got a graph down here. So again, we could take a look at it for every x value. So at -2, we had 1 point. At 0, we had 1 point. At 2, we had 1 point. And at 4, we had 1 point. That again tells us this is a function. But you can draw graphs of functions using your x value horizontally and your y value vertically. And then finally, we also can represent a rule or an equation. So notice we've got an equation, y equals 3x minus 2. The domain, again, since it's consistent with all of our other functions on the screen, that domain, right, was -2, 0, 2, and 4. Same thing in our table, same thing on our graph. Those are the only 4 points we plotted when x was -2, 0, 2, and 4. So to be consistent, a ruler equation doesn't have to have a limited domain. We could use any real number technically, but for this problem, we listed off 4 specific numbers, giving us back again 4 specific numbers in our range. So let's just take a look at a couple examples here. Tell whether or not the function, or the pairing, right, relation, if you will, relating x to y, is a function or not. So take a good look for just a second here. Would you believe that this mapping diagram at the left would make a function. And the biggest thing I would look at for sure is 0 right here. Because 0 went to 2 different places. Therefore, I would definitely say, no, 0 had 2 outputs. It's not going to be a function. Definitely not a function. Whereas now look at this table at the lower right. The inputs, there's 4 numbers. They're all different numbers, so no number is going to give me back 2 different answers. Right? 0 goes exactly to 1. 1 went to 2. 4 went to 8. 6 went to 12. All of the inputs have their own output. Therefore, yes, each input has exactly 1 output. Another thing we can do with functions is kind of work them forwards and backwards. Normally, we're not just going to identify, is it a function? What we'll want to do is work with it. So again, we've got an equation up here at the top, y equals 2x plus 5. But then we also have a given domain. So if they're going to tell me the domain is 0, 2, 4, and 6, what I'm going to do is put my 0, my 2, my 4, my 6, and 8 all down here on my table. Then what we want to do is plug those in to our equation. So let's start with 2 times 0 plus 5 is going to come out to 5, which means 5 is also a member of my range, but I'm going to wait until I see all the rest of the members before I list it off. I'd like to list low to high. So let's see what happens with the rest of my answers. So again, 2 times x, but x is going to be 2. We also want to do 2 times 4 plus 5. We're going to do 2 times 6 plus 5. And we're going to do 2 times 8 plus 5. This makes 9. Again, this is going to make 8 plus 5 would have been 13. 12 plus 5 would have been 17. And 16 plus 5 is 21. So again, there's my table, 0 through 8, skipping by 2s. Notice my y values actually kind of were consistent. They went up by 4s. But it says make a table. I did. For the given domain, only for those 5 numbers, only for what they gave me. And then identify the range. Well, my range is going to be those output numbers, 5, 9, 13, 17, and 21. And notice inside my sort of squiggly bracket there. That's how you work a function forward. We can input numbers and again get numbers back, those output numbers being called the range. Then we can also identify the rule or function. What if they give me a table and they want me to write it a different way? They want me to write a rule or an equation for the function. What I need to do first is spot the pattern. So notice I want to first look at my x values. I'm going to notice they're all going up by 1. 1, 2, 3, 4, 5. And notice my y values, they're all going up what looks to be by 8. 8 plus 8 would be 16, plus 8 is 24, plus 8 is 32. You could also look at it as whatever your x value is right now, right here. Well, 1 times 8 would have been 8. 2 times 8 is 16. 3 times 8 is 24. I think we have our answer. If I want to go up by 8s, right, every time x goes up 1, well, isn't 8 times x going to kind of accomplish that task? 1 times 8 would have been 8. 2 times 8 is 16. 3 times 8 is 24. 5 times 8, if we look down here at the very end, skipping down to the end, well, 5 times 8 would have been 40. But now remember, we want an equation. It's got to have an equal sign. And we're going to be equal to our answers. Again, x is your input. Y is your output. We're equal to those answers. Take a good look at the one on the bottom here. Now this one's a little trickier because notice the x values aren't going up by 1s this time. We're going up by 3s. So it's going to be a little harder to notice number to number. But if you take a good look at it, sometimes easier to relate your x's to your y's. -2 and 5 are about 7 apart. And notice 0 to 7, 3 to 10 is 7 apart, 9 to 16 is 7 apart. So what would I do to my x values to make my y values? Well, I'm thinking to get those y's, I'm going to take all of the x's, whatever they might be, and I'm just going to add 7. Again, the ones up top we multiplied by 8. These ones are just 7 apart. I'm thinking we can just add 7. 25 plus 7 down here on the end would still be 32. And there's my function. So again, there's some very basic functions. We'll do much more complicated ones as the year goes along. But if you have any questions about doing any of that or the definition of a function, talk to your teacher. Otherwise, have a great day.